Hello, and welcome to this series on understanding TPL data flow. My name is Erez Testeler, and in this series I'll be showing you what TPL data flow is, how you can use it in your applications, and what benefits it brings when you're programming multi-threaded applications. So let's get started. Okay, so here's what we're going to cover today. First I'll start off with where you can find TPL data flow. Then I'll give you an overview of what TPL data flow is all about. From there we'll move on to the functions of blocks, and blocks are just the components that make up a data flow. Then we'll talk about message propagation. How do messages actually flow through these blocks? Next we'll talk about block completion, and finally I'll talk about linking blocks together to form these data flow networks or pipelines. Okay, so where can I find it? So TPL data flow is actually part of the Microsoft .NET framework. However, it is not actually shipped with the .NET framework. So how do you get it then? Well, Microsoft has NuGet, and that's the way they release updates to TPL data flow. So if you're in Visual Studio, you can go to your references for your project, right-click that, and go to Manage NuGet Packages. From there, if you just search for TPL data flow, you should see the project, the package, and the results, and just install it from there. You can also just go to the package manager and then enter the command install package microsoft.tpl.dataflow. Okay. So what is TPL data flow? This is actually not TPL data flow. So what really is TPL data flow? So TPL data flow is a message passing asynchronous programming framework. So what does that mean? Well, if you think about it like this, you have data that's being produced. A data can be represented as a message, and you want to do something with that message. You have some sort of processing that you have to do to it. And ultimately, you may have multiple steps of processing for this message. And with TPL data flow, what you get is a more declarative model and a higher level of abstraction for asynchronous programming. So if you have multiple steps, and these steps can occur asynchronously and in parallel, this library gives you a way to do this and declare little blocks, little pieces of functionality for your processing, and then have them all linked together. And really it's the linking and the propagation of these messages that saves a ton of programming that you would otherwise have to do yourself using low-level constructs with synchronization and threading. Okay, so TPL, where does TPL in the name TPL data flow come from? Well, TPL comes from the fact that TPL data flow sits on top of the task parallel library. So in .NET 4, there was an introduction of system.threading.tasks, which gave a nicer abstraction of dealing with multi-threaded code as well as dealing with asynchronous operations. So TPL data flow sits on top of that, and it uses tasks underneath the hood to do its internal processing. The next thing is blocks. So blocks are the pieces that form these networks. They're the individual blocks of functionality that you wire together to produce pipelines and networks in TPL data flow. And we'll go and talk about more on that in a little bit. So messages flow through these blocks asynchronously. Now that's very important to understand, because what happens is in a flow, you typically are producing data, and it's being processed and being passed out to the next block. And you want to do this asynchronously, so processing somewhere down the pipeline doesn't stop messages from being pushed into it. And the whole asynchrony behind TPL data flow allows things to happen in a much more asynchronous fashion, and it eliminates a lot of your synchronization code that you would have to write otherwise. So let's talk a little bit about the functions of blocks. So blocks can consume data, meaning that they are targets for data. They consume data that's passed to them. They can produce data, so they can be sources of messages, and messages can be passed out of them. Or they can propagate data. They can be both targets and sources. So they can take in data, do some processing, and output more data. Now let's talk a little bit more about message propagation. Like I said previously, messages propagate asynchronously. And once we go through the individual blocks that come out of the box, you'll understand this better. So blocks can also propagate messages to multiple targets. So as you can see down in the image below on the left, you have a single source that's hooked up to two targets. So you don't need to have a linear pipeline where you have source, target, source, target. You can actually have a source hooked up to multiple targets. And usually, the first target to consume a message results in the removal from the source block. So what does that mean? So take this picture for example, where the source has two targets. The source will offer the message to the first target. The first target now has the ability to consume that message and take ownership of that message. However, it doesn't have to. It can postpone the message, which then the source now has a chance to offer to the second target. So the thing to just remember here is that when you're hooked up between a source and multiple targets, the message gets propagated to the target that consumes it first. And the next thing is that targets can receive messages from multiple sources. So just like you can have multiple targets for a single source, you can have multiple sources for a single target. Okay, so let's get a little bit deeper in message propagation. So sources offer messages to targets. So what does that mean? Just because a source is offering a message to the target doesn't have to accept it. So what can the target actually do? Well, the target can choose to either consume, postpone, or decline messages. Now let's say the target consumes the message. So what happens when the target consumes the message is that the message actually changes owners. It goes from the source to the target. If, however, the target decides to postpone the message, the target can store that message in an internal queue. However, it does not take ownership of it. It still remains inside the source. And if the source is tied to multiple targets, it will then offer that message to the additional targets after that first target. The third option that the target can choose to do is decline the message. And when it does that, it says, I don't want this message, and it will never be offered that message again. Targets can also reserve and release messages. So there are certain targets that are built into the TPL Dataflow library that can be hooked up to multiple sources. And when it's hooked up to multiple sources, it may wait for messages to come in from both those sources before doing what it needs to do. And so the way that this works, and it does it atomically, is that when a message is offered to the target from one of the sources, it can choose to postpone that message until another one arrives from the second target, from the second source. Sorry. And once it has a message from each of the sources, it could then reserve each of the two messages and then consume those messages. By doing that, it does it atomically. If there is another target that's hooked up to those same two sources, if that target has already started to reserve the messages, the first target will not be able to complete its transaction, and the second target will be able to do that. So what happens with the first target after it's tried to reserve? Well, it's got to go ahead and release that message. So that's what would happen there. Reserving and releasing messages are for more advanced scenarios, and there are blocks that use these semantics that come out of the box, and we'll talk about those in a next video. Okay, let's talk a little bit about block completion. So block completion tells a block not to expect any more messages. And what that means is you're basically telling the block that you want it to gracefully continue to process what it has internally and then not to expect any further messages. You want it to complete doing its processing. Okay? So completing allows a block to finish processing its queued messages. Blocks contain a task object that represents its completion. So what that means is you have an object that you can either wait on or await or run a continuation after you know that a particular block has completed processing its messages that it owns. Completion can also be propagated through configuration. And we'll talk about that in a little bit, but basically you can tell a block to tell its targets to complete when it's done with its processing. Blocks can also be faulted in order to represent an error in processing. So this happens a lot internally if a block is doing some sort of processing and one of the messages causes it to fault. At that point, faulted blocks do not continue to process any more messages that are being queued up, and they just terminate. So let's talk a little bit about linking blocks together. Blocks can be linked together to form these networks and pipelines of functionality. And the real benefit you get with the TPL Dataflow library is the fact that you can build out these networks and pipelines of asynchronous processing. And we'll see more once we get into the internal blocks and into some code. So there are a few configuration options that you have when you are linking blocks together. Targets can be prepended to a source's linked targets. So like I said earlier, a source can be linked to multiple targets. So when you link targets, they get appended into a list. There is a configuration option that lets you add a target to the front of that list. Links can also be automatically broken after a configured number of messages are propagated. So for example, if you have a source and a target, and you only want 50 messages to go over and be processed by that target, you can define that number when you're creating the link, and then after that 50th message has gone over that link will now be broken. And finally, completion propagation is configured when you create the link. So if you complete a source block and you want its target to complete, when the source is done pushing data out of it, you can do that when you create the link. So what have we learned? We learned that TPL Dataflow is a message passing asynchronous programming framework. We learned that blocks are the core components of TPL Dataflow. We learned that blocks can be sources of data, targets of data, or they can propagate data by being both sources and targets. We learned that source blocks offer data to targets, and targets have the option of either consuming data, postponing the data for later consumption, or declining data altogether. Messages propagate asynchronously between these blocks. And finally, we learned that blocks can be linked together to create more complex networks and pipelines of asynchronous programming functionality. So next time we'll cover blocks that are built into TPL Dataflow, and we'll go ahead and dive into each of the blocks' behaviors and take a look at code relating to each of these blocks. And we'll also talk about ways to configure and change the default behaviors of these blocks. I hope you've enjoyed, and thank you very much.